Hey everybody, so today we're going to be doing lateral movement and pivoting. And the first thing we need to do is just go ahead and start the room and give it a quick read over so we can understand what the ask is here. So looking at the introduction, it says this room will look into lateral movement, a group of techniques used by attackers to move around the network while creating a few alerts as possible. We'll learn about several common techniques used in the wild for this end and tools involved. It is recommended that we do breaching AD and enumerating AD before this one, and familiarizing ourselves with the lateral movement, techniques used by attackers, learn how to use alternative authentication material to move laterally, learn different methods to use compromised hosts as pivots. All right, and then connecting to the network. So if you're using a web-based attack box, you will have to be connected to the network automatically if you're using theirs. If not, you're going to have to configure it. So it looks like we need to also get the um, lateral movement and pivoting VPN file as well. So first thing I'll do is go ahead and grab that file. Okay, so we'll go to access. Okay, I'm going to share it. So go to access, and then when you go to access, you should have ability to go to networks and then go to lateral movement and pivoting. Okay, I'll download the file. And then once it downloads, then I'll just transfer it over to my box. So I'm going to minimize this. There we go. All right. And now what I'll do is I'll go ahead and transfer it over here. And I'll open this up a little bit so you can see it. All right, and I should have it somewhere here on my desktop. Odd, I don't see it. Expense. Maybe I didn't transfer it all the way. All right, now that I have the file over here, I'll put it in that THM folder. I'm gonna go ahead and create a terminal here. All right, open up a terminal. We'll do sudo open VPN with the name of the file. All right, and it's running now. And next thing we do is we'll go ahead and open up the browser. All right, and then we want to make sure that we're connected. So you can just go here, go to networks. It says, we'll go ahead and refresh this. It's showing online. It's not showing connected. It's a little concerning. Oh, never mind. Yep, it's showing online connected. It's giving us our IP address here. This is great. I am using Visio to create a network topology type drawing. This is just for me, so I don't like so I'm aware of the different PCs that we're dealing with here. So this one right here, I guess this could be mine, and so I'll just enter my IP address here. great. Go ahead and change that to white. And I'll put Kelly. Great. So now I know my IP address. So as I'm working through labs, I don't have to keep open up ifconfig to figure that out. All right, so now that we know that, go ahead and go back to the room. Looks like we have 1 hour left. Extend that 2 hours. Great. Go back here and let's see. You've got this OpenVPN connected. You want to go into the network manager. And probably put the IP address of the main server here. So pull up my notes for this one. Pull my notes on how I was able to do this last time. Okay. All right, so we'll just go ahead and minimize that. Come back over here. Terminal, NC connector, connection, editor. All right. NM. All right, I'll go here to wired one. Check the IPv4 address, and we'll change the DNS server to the IP address of the DNS server here. So go ahead and go to my drawing here, and I'm just going to, and you don't have to do this, of course, because you don't have this, but we have a server over here, so I'll put the server IP address there for our server. 10, 200, 124.101. I think that's a 4. Yeah, that's 4. All right, great. Looks good. Let's see, that's our server right there. Cool. So go ahead and minimize this. Go here. Drop that IP address in. And we'll do a second one here. It's going to be 8.8.8.8. That's for Google. Go and save that. Close it out. And then it says it's saved. All right. And next, we will need to go in here for the resolve configuration and just input the IP address of the domain controller. Right. And then I'll put name server. And I'll put the IP address at 10.200.124.101. Okay, Control O, save it, exit. All right, great. So we got that done. And we'll do what they say to reset the networking service. Complete. All right. And we'll do ifconfig. And I'll just take a look at that real quick. If I do ifconfig lateral movement, you see the IP address right there. I'm just gonna double check that with what I have in my topology. That's exactly what I'm saying. Okay, great. So now I'll try to ping the domain controller forward 1, and I'm getting responses. All right, cool. So we've got all that set up, and we should be good to go now. So next order of business is to just follow the instructions. I guess here. Requesting your credentials. We need credentials for this. I guess we do. Yeah, okay. So we're gonna have to go to this URL, and then for SSH access, we'll have to do this. Okay, so let's do this and come over here, open up Chrome, which I have right here. Give it a second. All right, now that Chrome's all open, just type in the IP address or that URL that they give us here. Might be able to copy it. Let's see. Yep, yep, there it is. Get creds. And here are creds. Okay, so what I'm going to do with these creds is I'm going to go back here to my little network topology, and we're just going to put the creds for this domain as being, let's grab this here, copy it, come over here, and here, just going to creds domain. And obviously you don't have this, so just put it in Notepad or something. If you have Visio, I think it's pretty cool. I like it. You know, it's definitely not free. You have to pay for it. It's even if you have an O365 account, you still have to pay for it. So it's something I like using for sure, especially since I'm now getting prepared for the OSCP and I'm dealing with like large networks. So I have to kind of stay organized. This is how I like to stay organized. So, all right, cool. So we are good to go. Let's move on to task 2 now. Oof, a lot of reading here. What is lateral movement? Simply put, lateral movement is a group of techniques used by attackers to move around the network. Once an attacker has gained access to the first machine of the network, moving is essential for many reasons, including the following: reaching our goal as attackers, bypassing network restrictions in place, establishing additional points of entry to the network, creating confusion, and avoid detection. While many cyber kill chains reference lateral movement as additional steps in a linear process, it is actually part of a cycle. During this cycle, we'll use any available credentials to perform lateral movement, giving us access to machines where we can have um, escalate our privileges and extract credentials. If possible, with the new found credentials, the cycle begins. So initial reconnaissance, initial compromise, establish foothold, escalate privileges, internal recon, move laterally, maintain persistence, complete mission. All right. Usually we'll repeat this cycle several times before reaching our final goal of the network. In our foothold is a machine with a very little access to other network resources. We might need to move laterally to their host. Okay, so quick examples. Suppose we're performing a red team engagement where our final goal is to reach the internal code repository where we'll get our first compromise on the target network. We'll use a phishing campaign. Usually phishing campaigns are more effective against non-technical users, so our first access might be through a machine in the marketing department. Marketing workstation is typically limited through firewall policies to access any critical services on the network, including administrative protocols, databases, monitoring services. Others that aren't required for their day-to-day labor, including code repositories. To reach sensitive hosts and services, we'll need to move to other hosts and pivot there to our final goal. To this end, we could try escalating our privileges on the marketing workstation, extract local user password hashes. If we find a local administrator, the same account may be present on other hosts. After doing some reconnaissance, we find a workstation with the name dev101 PC. we use the administrator password hash to access dev101 and confirm it is owned by one of the developers in the company. From there, access to our target code repository is available. Notice that while lateral movement might need to be used to circumvent firewall restrictions, it might also be helpful to avoid detection. In our example, even if the marketing workstation had direct access to the code repository, it is possible, it is probably desirable to connect through the developer's PC. This behavior would be less suspicious from the standpoint of blue team analysts checking log audit log. All right, and then it says here you have a difference between the administrator and the UAC. So the administrator will use typically two groups. There's the local administrator account group, and let's think of that. The purpose of that is because sometimes you'll have IT go out and they'll go to the computer and they'll perform an administrative function on the machine, and all they need to do is enter their local administrator password. They don't have to remote into it. These are typically like the new guys who might work at end user support, and what they would do is they don't need to remote into the actual PC, right? And then you have another group, and that's going to be your domain administrators. And so your domain administrators, they will have access to remotely connect to a PC, right? So the difference here, local administrators may physically go to the computer and perform administrator functions, and domain administrators will have the ability to remote into the machine and also perform the functions at the actual system if need be. So domain admins are way more powerful than local admins. Local admins are limited, and you may not be able to like pivot and stuff. So that's just what they're telling us here. You also have UAC, the user access control. So whenever you try to perform any type of um, admin privilege commands, it's gonna prompt you to enter your admin credentials. And so that's just a security control type feature that Microsoft has added, although there's ways of bypassing it. And if you ever stay up to date with patching, you'll always see that there's this new exploit for UAC, and then like Microsoft will patch it, and then you know the malicious actors, they'll create another UAC bypass. It's constantly happening. You'll constantly see that CVE. So let's move on. Task 3, we're going to be spawning processes remotely. So looks like we're using PS exec to spawn a process here. So I'm just going to read through this. The way PS exec work is the following: connecting to the admin share and upload a service binary. PS exec uses PS exec exe as the name. Connect to the service control manager to create and run services named PS exec and associated the service binary with the actual binary, and then create some new pipes to handle SDIs, SDouts, and SDDirs. So upload service executable, right? And it's going to do that via the admin share, and then create executable service. So then it's going to create that service, and then you're going to be able to perform your accounts, your commands through that pipe. So to run PSExec, we only need to supply the administrator credentials from the remote host and the command we want to run. And so it looks like they have it. It's available under tools. If you access the them jump to from your credentials, so from here we can access them to via Ramina, and then we'll perform these commands. So let's go ahead and get started with that. Or actually, I'll read through it because they may want us to just read up on it. So we'll read through it first. All right, another option we have here, remote process creation using WinRM. And so WinRM uses port 5985, 5986 for HTTP, HTTPS. The Windows Remote Management is a web-based protocol used to send PowerShell commands in the Windows host remotely. Most Windows Server installations will have WinRM enabled by default, making it an attractive attack vector. To connect a remote PowerShell session from the command line, we use the following commands. So winrm.exe, admin, and then those credentials. We can achieve the same from PowerShell, but to bypass different credentials, we need to create a PS credential object. So you create your username, password object, and you convert that password can only be stored encrypted. So you have to convert it to a secure string, and then you can then pass those credentials to the machine you want to access. All right, and you can also do it this way as well. But you need to, again, make sure you create your credential objects. And then here you can run a script. So if you don't want, you just want to connect to it and run a script automatically, and you don't want to have like interactive session, then you can do that as well. So creating services using SC remotely. So you support 135, 49152 through 65535, and uses port 445 RPC over SMB name pipe, 139 RPC over SMB name pipe. Require group membership administrators. The Windows service can also be leveraged to create arbitrary commands since the executed command when started. While a service executable is technically different from a regular application, if we configure the Windows server to run an application, we will still execute it and fail afterwards. We can create a service on a remote host with sc.exe, a standard tool available in Windows. When using sc, it will try to connect to the service manager remote service program through RPC in several ways. A connection attempt will be made using DCE RPC. The client will first connect to the endpoint manager on port 135, which serves as a um, available RPC endpoints and request information on SVCC service program. EPM will then respond with the IP and port to connect to SVCC which is usually a dynamic port in the range of that. So whereas SVCC SVCTL is using this port, RPC bind to it. If the latter fails, SC will try to reach SVCTL through SMB, either on port 445 or 139 over NetBIOS. So try to reach that. We can create and start a name them using the following command. So, all right, we'll put in net user, their name, password, and we'll create this service. Start them service. Net user command will execute when the service started, creating a new local user on the system. Since the operating system is in charge of starting service, you won't be able to look at the command output. Okay, so it looks like we're creating a new user and we're starting that service. And to stop or disable the service, we can run these. Creating scheduled tasks remotely. Another Windows feature, we can use schedule tasks. We can create and run one remotely, schedule tasks available in Windows installations. To create a task name, then task one, we will use the following schedule task and then the command. And then we run this to actually run that command. We'll use schedule task sc once, which seems the task is intended to run only once at the specific date or time. Since it will run tasks manually, the start date, SD, and ST won't matter as much. So schedule task, okay, SC, gotcha. Finally, to delete the scheduled task, we can use the following command, delete. All right, so let's get to work. And it looks like we're going to be using all the methods we learned here. Interesting. To complete this exercise, we'll need to connect to jump 2 using the credentials assigned to us. If you haven't already done so, go there, get your credentials. For this exercise, we have already captured credentials, remote access. These are the credentials. And let me just verify those are the credentials I have. Those are not the same as the ones I have. So first, I guess we're going to SSH into this box. We're going to SSH into them too, the jump box. Let me get my jump box's IP address here. What is the jump box here? Ah, there it is right there. All right, so looking at the network topology here, we'll create a box here. Flyer, all right. And then two jump boxes, 10, 200, 124, 249. And the name of it is jump.u2. All right, cool. So what we'll do is we'll open up Kelly here. And we'll just go ahead and connect to it. So use the command they provided here. Sorry, username is Jennifer. Right. And password is right there. Okay. This, grab that. Come over here. And we're going to drop that in there. Yes. Put in the password. All right, we're in. Who am I? Jennifer. All right, great. So we're in the jump box now. These are admin credentials. So I'll say, all right. And so admin creds right there. All right, so we'll show you how to use these credentials to move laterally using sc.exe. Feel free to try other methods as they should work against stims. Well, we already shown how to use SC to create a user on a remote system by using net user. We can also upload any binaries we would like to execute and associate it with the created service. However, if we try to run a reverse shell using this method, we'll notice that the reverse shell disconnects immediately after execution. The reason is that this service executables are different standard exe files and therefore non-standard. Non-service executables will end up being killed by the service manager almost immediately. Lucky for us, NMSF Venom supports exe service formats, and we will encapsulate any payload we like inside a fully functional service executable preventing it from getting killed. To create a reverse shell, we can use the following. Since you'll be sharing the labs with other, you may want to use a different name for your payload for myservice.exe to avoid overwriting someone else's payload. All right, great. So what I'll do is I'll go ahead and grab this. And then what we'll do is we will name this, or actually, just make this a lightning bolt. Service executable, we'll name our executable, my service killer. Yeah, sounds cool. So here you can see I've added a lightning bolt, my service killer.exe. So now what I'm going to do is I am going to create this using MSF Venom, and I'll just open up my PowerShell. Just open this up. And I'm just going to drop this in here. So open up a terminal from here, over here. Oops, that's not what I wanted. All right, I'm going to grab this command here. Your MSF Venom command. And I'm just going to open up Mousepad actually and just drop that in there because I have to kind of do some editing here. All right, here we go. All right, and let's see, my server's using. We have to change this to our IP address. Put 10.50.121.228. All right, and my service is killer. And now you can see that here's looking good. All right, now that we have this set up, we're going to go ahead and press enter. Or actually, just Control A, Control C, and we'll come over here, drop that in there. Got that in there. All right, now that we have that done, we'll go ahead and list this out. Let's see that our payload is right there. Go ahead and move over here, see what else is next. We will then proceed to use these credentials to upload our payload to the admin share of THM IIS using the SMB client from our attack box. Okay. Okay, gotcha. SMB client. So this is what we need to run from our attack box. I don't think it's from the jump server, but because the jump server would have like Windows commands, right? So I'm gonna grab this command, come over here, open up my mouse pad, and drop that in here. And we have our credentials. All right, looks good. Just have to change that name, my service killer. And then we can then copy it and there we go. And then upload a terminal from here, open up a terminal from here, and then just drop that in. And it's asking for this user's password, which I have my little diagram, so I'll grab that real quick. So go ahead and grab your Nardo password. All right, and it's uploaded. Great. So we've uploaded that to the file. Yeah. SMB, cool. Our executable payload is uploaded. We'll then set up a listener on our attack machine to receive the reverse shell. All right, so what we'll do next is just copy those commands. So console, wait for it. I always like when it starts up and then it'll show you like a little picture or something. Don't say the magic words. Okay. And next we'll use exploit multi-handler set all host lateral movement set L ports 4444 set payload Windows and then actually there we go here. Just grab whatever they have here. All right, and then we'll type exploit. So now we got that set up and waiting. And then we can run this command. It's just a long strung out command of what we just did. All right, and then now we can, since sc.exe doesn't allow us to specify the credentials as part of the command, we'll need to use run as to spawn a new shell with Leonardo Summers access token. Still, we only have SSH access to the machine, so if we try to do something like run as not only user, the new prompt would spawn on the user session, but we only have, we would have no access to it. To overcome this problem, we can use the run as to spawn a second reverse shell with Leonardo Summers access token. Okay. All right, it's interesting. So run as net user. So we're running this command as another user, Leonardo Summers. We're using netcat, which is already on the machine, to then cmd exe and then connect to our reverse shell. Okay. So what we need to do now is we have all these sessions open. This one's waiting for incoming connection from the payload. This is just mouse pad. I'll just move this over here somewhere. This is where we need to work from. This is the connection we have with the jump server. And then looks like we're connecting to, so what we'll do is we'll take this command here, right? Working through this. We have mouse pad open, just click on that, come over here. We'll edit this a little bit here. So we need to put in the IP address of our attack box right here. All right, looks good. So now that we have that good to go ahead and grab this, come over here, drop this in there. Oh, there we go. And then just enter. It's asking for the password, so enter the password. Drop my little diagram. Go ahead and grab that over here, copy it, come over here, drop that in, enter. And it looks like it has started a connection, which, oh, of course, I did not start the connection for that port. I'm just going to start that baby up. And which Is that on 443? Yeah. All right, cool. So I'm gonna try that again. Should have started the connection first. All right, now we got a reverse shell connection. So now we got this connection to these IIS servers. So host name, this is jump to who am I? Jennifer. Okay. All right, so it's Jennifer. All right, let me make sure that ran correctly. All right, remember that since this is using run as and net only options, it will not bother to check if the provided credentials are valid. More information on this later. So be sure to type the password. So be sure to type password correctly. If you don't, you'll get an access denied error later in this room. Okay. You can receive a reverse connection using NC. And finally proceed to create a new service remotely by using SC associated with the upload binary. Okay. So next, we are going to start our malicious binary from our new command shell. So, and when we do that, we will then have access via interpreter to it. Let's see if this works. We'll grab this. See, I have two open, which this is the one that we just spawned on 4443. Come over here and drop this command. Ew, it said it failed. Service already exists, of course. This is so yeah, this is remember how I told you we had to rename it? Oh, okay. So go to your mouse pad and gotta do the service killer. Service killer. Service killer here. There we go. Now it should run correctly. Somebody didn't change the name of theirs as well, so it's good to know they're not following instructions. Ugh, oh god dang it. It's saying the service killer's already there. So, yeah. Hmm. Alright, that did not work. Oh, you know what? Finally, to create the process a new service by using SC associated with our upload service. I think maybe we need to change the name of that service. So instead of 3249, we could make it something else, something random. So let me try that out. So make it 233. Yay. All right, so yeah, I just need to change the number of the service. All right, cool. So next, go ahead and grab this next command and make sure you have a history of these commands. Do what I'm doing, like copy them all down. So then you're gonna forget, like, wait, what number did I put? Did I give that command to go through? So this one's 32, 33. You can name it whatever, it doesn't matter. And it's called them service. So go ahead and grab this, paste this in here, paste it in there. we should get a connection back. Just spun this up a little higher. Okay, so make this a little wider. I've heard people say that it's kind of, I need to like zoom in a little bit more, and I'll try zooming in. It's just, let's just work through this first because I've got a lot of windows open. So, yeah, there it is right there. So we have a connection back. So this is ultimately what we wanted, right? Um, this is ultimately what we wanted. So let's go ahead and recap on this one. So I'm gonna go here. I'm just gonna scroll up. We have the IS server right here. So excuse me. All right, so go to my drawing. Here's the drawing. And put, that's an IIS server. Okay, so we put another server right here. Put like a little box here. It's 10, 200, 124, 201. Let's go sim IIS. All right, so what we did was we got our payload from jump 2 right to over here in dim IIS, and we got our payload service killer. We then ran that service, and what that did was it then add these connections here, arrows. It then allowed us to establish, oh, that then allowed us to establish a connection right back to our Kelly box, like that. And what we're using is we're using a jump box. So this is very normal to do, to use this jump box for our initial access. So this is how we got our foothold. And then from the foothold, we're able to gain access to other machines like that, right? So that's what's going on. And let's go back over here. We can do get UID or system or GUID. Oh, we're on a normal, this is the normal shell. Oh, I thought this would be an interpreter shell. Okay, no worries. We can upgrade it later if we wanted to. But who am I? We are NTLM Authority. That's great to know. So host name, this is the IIS server, right? Yeah, this is the MIAS. And we'll just go back a few directories here. I like to start off from other directions, but we'll see where we're going to go next, right? So we've gone through that. It's going to ask us for a flag here. After running flag.exe file server, file on our summers on MIS, what is the flag? Oh, okay, so there's a flag.exe. Where the heck is it? It looks like it's in his desktop. Okay, so go to CD. That is what I thought they would make us do. So users and CD, or we'll do a dir, and we have Leonardo Summers right here. Just gotta get the correct name, syntax. Grab it, copy, CD. All right, CD desktop. And we'll type the flag. or actually just run the flag.exe. So we'll see what's up here. So we got flag.exe, so we'll run that. And then here you can say it's them moving with services. So that's your first flag. So you go ahead and paste that over here. You get your first flag right there. All right, so next we're going to be doing moving laterally using WMI. So WMI, we're going to have to create this credentials. So before we're able to connect to WMI using PowerShell commands, we need to create a PS credential object, and this is how we're going to do it. We then need to proceed to establish WMI sessions using either protocols, DCOM, RPC over IP will be used for connecting to WMI. This protocol uses port 135 TCP and those ports. Just explain what sc.exe, WSMan, WinRM will use the following to connect to WMI. This protocol uses the following: 5985, 5986. To establish a WMI session for PowerShell, we can use the following commands and store the session on the session variable, which we'll use throughout the room in different techniques. So we'll use new session, we're going to use dcom for our protocol, and then create our session using that here. You still need to do this. You can't skip this step. You still need to do that. The new CS session option command line will be used to configure the connection option for WMI session, including the connection protocol. The option and credentials are then passed to the new CM session C commandlet to establish sessions against a remote host. Remote process using WMI. All right, so we can remotely spawn a process from PowerShell by leveraging the Windows management instrumentation WMI, send WMI request to Win32 process to class to spawn the process under the session we created. So we can use this command, PowerShell exe command, the path, invoke CM session class 32 process method, create arguments, and then the command that you want to pass. Or actually, this would be the pass. This would, I guess, would be the command to set content path to create a file test.txt with the value with that value. Notice that WMI won't allow you to see the output of the command, but will indeed create the required process silently. On legacy systems, the same can be done using wmic from the command prompt. So wmic, username, passwords, create cmd, and then it'll spawn a calculator. Creating services remotely with WMI. So ports 135 TCP and 5985 for WinRM, HTTP, administrator groups is required. We can create services with the WMI through PowerShell to create a service called them2. We can use the following command. So create a service named them2. Your payload looks like they want to create a new user. Start service, so then we start the service. Then after we get a handle on this service, we can start with the following commands. Then we start that service. Finally, we can stop the service and delete it with this command. Creating scheduled tasks remotely with WMI. Right. We can create and execute scheduled tasks using the following commandlet in Windows default installations. Payload must be split in the command and arguments. So command cmd.exe, the arguments is to create the new user. actions is to concatenate all those things that we've just done and to register the service and to start it. To delete it, we can use this following command: install MSI package through WMI. So port 135 and 5985, so MSI is a file format used for installers. We can copy an MSI package to the target. We can use WMI to attempt to install it for us. The file can be copied in any way available to the attacker. Once MSI file is on the target system, we can attempt to install it by invoking Win32 product class through WMI. So invoke CMS session uh, class name Win32 product install argument, and then um, so MSI package is kind of like the executable, like a set executable, set everything up. So we're gonna run this. We can achieve the same by using the wmic. So this will also start the MSI installer. So let's get to work. To complete this exercise, we'll need to connect to THM jump 2 using our credentials, which we're already connected. If you haven't already done so, for this exercise, we will assume we have already captured the credentials of this admin. So this is a different admin. Okay, so even though we're connected to the jump server, we can't use the credentials we just used. Like we have to use these new credentials. So we'll show how to use those credentials to move laterally to them using WMI and MSI package. Feel free to use other methods presented during this task. We'll start by creating MSI payload with MSF Venom. Since this is a shared lab, we're gonna have to rename our payload from my installer MSI to overwrite, so we don't overwrite somebody else's. We'll name it my installer killer MSI. And now that you're watching this video, you probably have to rename it something else because someone's gonna watch my video and who knows, they may name it killer. So you have to name it killer 2 or something of that sort, right? Just be aware of that. We then copy the payload using SMB and other methods available. So we're gonna then copy that to this jump server. Since we copied a payload to admin share, we can use the available Windows C or C windows on the server. All right, start another Mesploit. This one's running on 445 instead. Let's start our WMI session against the MISS. All right, so we're gonna put in those credentials. Start our object, create our credentialed objects, create a new session with WMI. I'm just reading through this right now. We will then invoke the methods from 132 product class to trigger the payloads. Then we will say it's on jump 2. Invoke 132 product my installer.exe. Okay. As a result, we should receive a connection in your attack box where you'll have access to the flag on the desktop. Okay. All right, looks like a lot of work. Let's get to it. So first thing we're gonna do is just maybe start a new desktop. Let me see if I could do that real quick. So if you click here, you see how this is the 1, put number 2. We'll have a new desktop so we don't get everything confused. I'll open this up. And we're going to SSH using those credentials to them jump 2. So let me look at our topology here and see if them jump 2, them jump 2. Okay, so Oh, this is dim jump 2. Okay, so we've been using dim jump 2. Just want to make sure it wasn't you. All right, so dim jump 2, we can use the same commands we used earlier for dim jump 2. So I have it saved here, but it would be the ones that the credentials you were provided when you first started, right? And so I'm just gonna grab that, come over here, and just drop that in there. I'm just gonna ask for the password. And I'll provide the password. Well, creds, what is the password of this? Oh, it's acknowledge. There we go. I have the password here too. It's a good thing I've kind of stayed organized because this really helps. So let's drop that in there. If you're wondering what I'm looking at this right here. The credentials right there, so it's easier for me to remember. Okay, so next we look at the rest of these commands here and open up another mouse pad. This could be a different mouse pad. And we're going to create this payload. I will use Immersive Venom to create it. I do want to put the payload inside of that folder I have in my desktop here. I'll open up the terminal from here, come over here, and we're gonna have to adjust some things here. So let me actually put that mouse pad right here. Drop that command in there. Come back over here. We've got our IP address for our talk box, so copy that. Come back over here. I'll just put that IP address here. All right, looks good. We're gonna have to rename this, so rename it killer. And then we'll just grab this command here. Copy it, come over here, paste it. All right, so it's creating our reverse shell here. And once this is done, we'll transfer it using SMB client. I'll do something over here. Grab. Open up this pad. Don't have to change these credentials because they're the credentials that we're just provided right now. So that looks good. So now we can just grab this. Oh, wait a second. So change this from my installer. Make sure it says killer at the end, right? Yeah, there you go. Now I'm gonna grab this command, copy it. Here, drop that command there. Boom. It's gonna ask for the password. Password is right here under passwords. Karina 94. Okay, that worked. Now what we're gonna do is we are just going to start up another MSF console. Okay. There's my little picture. All right, so let's just copy the commands they have here. Be quicker. All right. Oh, okay. Oh, I forgot to do a very important thing here. I forgot to use the multi-handler exploit. That's why none of my stuff was working right now. Use multi-handler. Now we can just enter everything we just entered. So I'm gonna go back up here. So set alpha zone. I'm gonna set the output, and then after that, you have to set the payload. Now we can type exploit. You see me just going through the history. All right, so next, let's set up WMI session against THM So go here. All right, so let me make sure I'm reading this correctly here. Looking at this, all right, so looking at this. So we're gonna have to put in the username. So it gives the username, right? So we just have to type this in. I'm gonna copy and paste everything because I'm not about to type that all out. Oh man. All right, so great. It looks like it's saying it's not a recognized command. So I think we're in a CMD, so we need to do PowerShell. Once we do PowerShell, it should work. Yep, that's working now. All right, next we'll run the next command here. It's going to be creating our secure string. Next, we got the credentials. All right, next we got the decom protocol we're going to use. All right, and then after that, we have the session. We're going to create the session. It's all described in the variable, but pretty self-explanatory. All right, great. I'll click enter. And I don't believe we've told it to run that session. So that we then invoke the install method from the Win32 product class to trigger the payload. All right, so let me take this whole command here and we will put it in mousepad because we need to edit it a little bit. Here. All right, so we're gonna have to put killer at the end of that. And the rest of it looks good. So grab it, copy it, paste it. And it's saying that it's run. So now we should get a session here. Great. So who am I? NTLM authority. We have another session IIS, I believe. Host name. Yep. All right, great. So on them IIS. Great. So it's asking us to get the flag. on T1. So we'll do is type, I'm gonna do this quickly, C colon / users, put in the username. It's gonna be Karina Waters. Grab it from down here, right? Oh, there we go. Put that right there. Paste that in. Desktop. Flag. I don't know if it's a text file. I think it might be a exe. So we'll see if it's a text file first, I guess. So it doesn't look like it's probably an exe then. So that didn't work. So I have to do cd, and I could just type in this. All right, do dir. And yeah, it's an exe, of course. Okay, so flag. I could have just run it from there, but hey, let's verify. So moving with WMI for fun. So that's your flag, and go ahead and drop it there. All right, moving along. So task 5, use an alternate authentication method. Okay, so what are we dealing with here? NTLM authority, NTLM passing the hash, passing the hash. All right, Kuberos, my favorite. Kuberos is just, it's a lot to learn on Kuberos. Extracting some tickets, extracting some Kuberos tickets, loading those, passing those, starting some processes. Looks like what we're doing. All right, this is going to be fun. So great. Let me scroll back up here. It's going to be a lot of reading. So I'm going to stand up, take a stretch, and then I'll be back. I'm going to extend this another 1 hour. Recommend you extend it. You know, it's easy to lose track of time, and the next thing you know, you have to redo everything because your credentials expired. So go ahead and pause it. All right, back from my union break. Just wait. So now we're gonna read through this. I'm just gonna log in real quick and then we'll go ahead and get started here. All right, so um, use the alternative authentication method. By alternative authentication material, we refer to any piece of data that can be used to access a Windows account without actually knowing user passwords. This is possible because of how some authentication protocols used by Windows network. In this task, we will take a couple of alternatives available to log in as a user when either of the following authentication protocols is available on the network: NTLM authentication and Kerberos authentication. During this task, we'll assume you're familiar with the methods and tools to extract credentials from the host. Mimikatz will be used as a tool of choice for credential extraction. So NTLM authentication. Before diving into the lateral movement techniques, let's look at how NTLM works. So client authentication request, server challenge, client response. Do you see password? No, they're passing these hashes. Server challenge response. Domain controller who has the password can actually check to see if that challenge is good, denies authentication or allows authentication. So that's how that works. Pass the hash. So as a result of extracting credentials from the host, we have attained administrative privileges by using Mimikatz or similar tools. We might get clear text passwords or hashes that can easily cracked. However, if we're not lucky enough, we can use NTLM password hashes. Okay, so we could pass the hash, and to extract those hashes, we use privilege debug, token evaluate, elevate, and then token elevate will then give us the hash here. So the method will let you extract the NTLM hash from the user and domain user that has recently logged onto the machine. All right, we can then use the extracted hash to perform pass the hash attacks by using Mimikatz to inject an access token for the victim, user on a Rochelle, or any other command. So, hey, take that token and go ahead and inject it, cache it on our system, and then once it's injected and cached on our system, we can then utilize that token or in TLM hash to then gain access to the machines. Notice we use token revert to establish our original token privileges, as we are trying to patch the hash with our elevated token won't work. This would be the equivalent of using run as net only, but with a hash instead of a password, and we'll spawn a new reverse shell from where we can launch the command as the victim user. To receive a reverse shell, we can use a reverse listener. Okay, interestingly, if you run who am I command of the shell, it will show that you're the original user before doing pass the hash, but any command run from here will actually be the user's credentials that we've injected. Okay, so pass the hash using Linux. If you have access to a Linux box, like TAC box, you can actually utilize that to RDC, like remote into the machine. You can use it to use psexect, py, Python file, or EvoWinRM as well. EvoWinRM is a great tool you can upload very easily. All right, so Kubros authentication. Kubros authentication, boy, that's going to be a long one to read. Let me scroll down. Let's go ahead and just do a little bit of this. So this, it needs to see some activity or it'll time out. So we don't want our lab environment to time out. So I'm gonna go ahead and just hop over to my Linux box and we'll talk as we go. I'll go through all three of those as we go. We just don't want it to time out on us. So click on 3 here, go over here, spawn another mouse pad, and come over here. Then we got our next set of credentials. Take these credentials here. And I'm just going to drop these credentials over here. So I'll create a new box here. Put this box down here. Drop the credentials there. I like this white. If anyone's wondering how much does this cost, Visio, it's like $5 a month or something like that. But if you get the annual subscription, it's like 300 bucks. Crazy. I'm not planning to pay that much. I don't know. Maybe. That's a lot. All right. So next it wants us to SSH to jump to using these credentials. So we're just straight up SSHing into jump to is what it's asking us to do. So I'm gonna come over here. Just gonna drop this in here, drop that in there, and as soon as we get SSH, it's gonna ask us for what the password. So just have that ready to go. And why not? Cool. We'll open up a terminal. It's a new desktop area. Keep it clean, you know. Open up a terminal. Grab here. Come over here. Grab this. Copy that. Come over here. Drop that baby in there. Boom. See if it works. So that's for the password. Just drop that password in. And we're in. Okay, so there's some activity there. It's not going to time out on us. All right, great. So these credentials will grant you administrative access to DIM Jump 2, allowing you to use Mimikatz to dump the authentication material needs to perform any of the techniques presented during these tasks. Using your SSH session, use Mimikatz to extract authentication material and perform pass the hash, pass the ticket, or pass the key against the domain user one Toboy Beck. Once you have a command prompt with his credentials loaded, use WinRMS to connect to the command prompt on ThimIS since Tommy Beck's credentials are already injected in your session as a result of any of the attacks. You can use WinRM without specifying any credentials, and it will use the ones available to your current session. So Oh, I see. Okay, so then you use this to then spawn session. You'll find a flag on Dimlin Boy, Atomic Boy, blah blah blah, desktop, and then both Mimikatz and PSXX64 are available at Dim Jump 2 if you need to use those. Okay. Okay, so let's go ahead and scroll up then. I guess we'll use the first one we learned about, right? So it's actually one of the easier ones to do. And it's in a tools file. So let's do that. Let's get it out of the way. Let's go back and learn the rest. All right. cdc/tools. Tools. All right. dir. We got the Mimikatz here. All right, cool. I think Mimikatz is like, it's like foreign for cat or something. I don't know. So next we'll go ahead and run the Mimikatz. Run Mimikatz. You can just do dot backslash Mimikatz. Now you can see Mimikatz is running. Go ahead, come over here. And now that we have that running, we can do this privilege debug to make sure we have the privileges necessary to extract password hashes, which we do. Okay. And next we're going to do is we're going to token evaluate. And by doing that, it should dump some password hashes. Got the NTLM administrators. Scroll up a little bit. And we got Felicia. Is that it? Huh. All right, let me scroll down a little bit because I think we're missing something here. Oh, it is Felicia. No, Felicia, that's our current user, isn't it? Yeah. Actually, I don't think that actually dumped the hashes. I think that only allowed us to. This only from the local SAMs. But if you want to do it from the LSAS, then you run this command here, and this will extract the password, the hashes from the LSAS, which is like a database that keeps all the hashes. Oh, snaps, what I do. Yeah, so this command should work. Yep, yep. It's looking good. Oh, okay. So scroll up here. Tommy Beck. Is that who we needed? Tommy Beck. Tommy Boy. Tommy Boy. Yeah, we needed Tommy Beck. I'm just gonna call him Tommy Boy just because I do what I want. So, all right, next we're going to use PS session to then pass those hashes. So token revert, then extract the. All right. So this is gonna run it. CA try hack me, so that's the domain. I'm trying to check to see if that's the domain. So that doesn't look like it's running against the domain controller. That's not what we want to use. Here we go. This is what we want right here. Right, cool. So they already have evil win RM on here, right? Or something like that. Let me check. Scroll through here. We're gonna have to exit this. So but before we exit, yeah, no, we can exit this. Exit and dir. Yeah, we have psxx64. And all right, so we'll use psxx64. So what we can do is we can just copy this because my machine already has this, so we can copy this. Come over here. Uh, we can go mouse pad, and then copy the IP address of the domain controller. And then the user, which is that Tommy boy, whatever. That. No. All right, here we go. It's a weird naming convention, T1. I wonder why they name it T1. Topic. All right, so next we want to copy the hash that we just extracted with the Mimikatz. Let's see, cats. Topic. Here we go. It's right here. It's the hash. NTLM hash right here. And we'll copy that. We could also crack it if we wanted to. All right, so now that we have that, then we go back over here, come over here and just drop that in there. All right, and then now we should be able to just authenticate with this. Open up a new terminal here. Uses access. It's taking a long time. It's not a good sign. Let me see if I can ping it. They might want us to do the whole pivoting thing, but yeah, so it looks like it didn't like that. Or I didn't do it correctly. Probably more likely. All right, let's try the second one here. Like this one doesn't have the domain. All right, let me try this a different way. OpenRM. Oh, maybe it's I didn't quote it. Let's try that. If that doesn't work, then I guess I could try to locate PSXX. Okay, so I do locate and then PSXX. You can see it's found it here. You should have it by default here in the user's errors. So then go to that location and then run it from there. See if this works. See who they want us to pass this to. So they want us to pass this to jump to. Oh, it's on THM. No wonder it's not working. I was using the wrong machine this whole time. So I was trying to get access to the main controller, but you're supposed to get access to THM. So let's go back to the diagram here and let me correct that first one I did, because it probably would work if I did it correctly. So it's 201. 201. All right, so let's go ahead and try this again. Come back over here. Change that IP address. Hey, we're in. All right, cool. So that worked. So now I am going to and CD, uh, desktop, dir. We got the flag right there. Flag.exe. And then there's a flag right there, guys, girls. All right, so got that. Come over here, drop the flag in, done it. Got two more, and I'm gonna read through this really quick. Um, I already know how to do this portion, so I'm just gonna read through the Kuberos authentication, and I'll pause it, and we'll move on once I finish reading through this. All right, so I thought I could go over this really quick. So what's going on as I just read through it. So Kuberos, let's talk about Kuberos. So Kuberos, very simply, the user says, hey, here's my username, here's timestamp, sends that information to the key distribution controller, and that's the domain controller most of the times. Domain controller will say, okay, user, here's a TGT, a ticket granting ticket, and a session key. Okay. Then the client gets that ticket granting ticket. Ticket granting ticket allows you to then request a ticket granting service ticket, TGS. So the TGS request is sent from the client to the domain controller using the TGT that was just relayed. All right. Then the ticket granting service ticket request will reach the domain controller. Domain controller will review it, and if this user is legit and this is a legit TGT, it will send a TGS, ticket granting service ticket. It'll send that, right? So the first one was a request. The second one is here it is. So you're good to go. Then the client will then use that TGS to authenticate to services. So what it's saying here is we can use Mimikatz to extract TGSs. We're not so much interested in TGTs because the TGTs still need to be authenticated, but the TGSs, they've already been exchanged. So we can use that to start authenticating to services. All right. So then we can use that to extract it, load it into memory, load it in cache in our session, and then access these services, right? Is what's occurring. So that's basically what's going on here. I didn't read this second portion, but this is a kind of a text limit to pass the hash, but applies to Kubros. When a user requests a TGT, they send a timestamp encrypted with an encryption key derived from their password. The algorithm can be used to derive this key can be either be DES disabled by default on current Windows version, RC4. RC4 is pretty weak, so you can actually crack that if it is RC4. AES 128, AES 256, depending on the installed Windows version, those configurations. We also have those keys. We can ask the KDC for the TGT without requiring any actual password, hence the name pass the key. We can obtain the Kerberos encrypted key from memory using Mimikatz, depending on the keys that are available. On Mimikatz, get a reverse shell via pass the key. Netcat64 is already available on the jump. So we can run this to, let's see here what it's doing. It's caching that RC4 hash using the administrator to then authenticate and passing the hash of the administrator to then have the administrator run netcat and establish a remote shell, reverse shell from the jump server to our machine. But does that really help us? No, because in the second portion is where we have to actually connect to that IS server, right? So that's just showing you what's going on, right? And so it's showing you a few different ways to do it here with the different types of hashes. So RC4, it's pretty straightforward. AES, you have to specify it's AES, and then, you know, AS hash 256, you have to specify that as you pass the hash. So great stuff. Um, even though I went through the Pen 200 course, I learned all this. There's a few things that I don't, maybe they skipped over, maybe I wasn't paying attention, but this is how you authenticate with AS256, 128. I actually didn't know this. So, when you're going through these type of try hacking courses, I really have to put my ego aside and just focus on the material because there's information I don't know. There's always information I don't know. So next we'll go to abusing user behavior. All right, so here I'm just gonna review it real quick, right? So we have writable share. Okay. We are creating a backdoor VBS script. So it looks like we could write to this share, we could write to these scripts or something. Let's see, RDP hijack. Okay, and let's go to work. This is interesting. I've actually I don't remember doing this. So under certain circumstances, an attacker can take advantage of actions performed by users to gain further action to the machine and network. While there are many ways this can happen, we'll look at some of the most common ways. So abusing writable shares. It's quite common to find network shares that legitimate users use to perform day-to-day tasks when checking corporate environments. If those shares are writable for some reason, an attacker can plant specific files to force users to execute any arbitrary payload and gain access to their machine. One common scenario consists of finding a shortcut to a script or execute file hosted on a network share. Yeah. So you got the target, and it looks like they put a malicious target in there for, I guess, for it. The rationale behind this is that the administrator can maintain an executable on the network share. The user can execute it without copying or installing an application to each user's machine. If we as attackers have write permissions over such scripts and executables, we can backdoor them to force users to execute any payload we want. Although the script or executable is hosted on the server, when a user opens the shortcut on his workstation, the executable will be copied from the server to the temp folder and executed on the workstation. Therefore, any payload we run in the context of the file of the final user's workstation and logged in user account. Let me check my time. Make sure you guys check your time. Let's go and check our time now. And we have 1 hour, 2 minutes. So I'm gonna extend it. We got, oh, I cannot extend it. You can only extend time for maximum of 2 hours. Oof, okay. That must be new. I don't remember having that before. All right, backdoor VPS script. As an example, if we share resources of VPS script, we can copy the NC64 command on the same share and inject the following code in the shared script. So this is a VPS script, create object, run the command line, run or copy this and put in the temp directory and then run that cat and then start a reverse shell. This will copy NC64 from the share to the user's workstation directly and send the reverse shell back to the attacker whenever a user opens the VPS script. Backdooring exe files. If the shared file is a Windows binary, say putty.exe, we can download them from the share and use MSF Venom to inject a backdoor into it. The binary will still work as usual, but execute an additional payload silently. To create a backdoor putty.exe, we can use the following. So use MSF Venom to create a Trojan, basically. The resulting of putty.exe will execute a reverse TCP interpreter payload without user's notice. Once the user file has been generated, we can replace executable on the Windows share and wait for any connection using the exploit multi-handler module from Metasploit. RDP hijacking, when an administrator uses RDP to connect to the machine and closes the RDP client instead of logging off of this session, it will remain open on the server indefinitely. If we have system level privileges on a Windows Server 2016 or earlier, we can take over any RDP session without requiring a password. If we have administrator level access, we can get a system by any methods of our preference. For now, we will use psexec to do so. First, let's run cmd.exe as administrator. From here, we will run psexec64, list the tools, or start a command prompt, query the user. According to the command output above, if we were currently connected via RDP using the administrator, our session name would be RDP TCP 6. We can also see that the user named Luke has left the session open on 3. Any session with disk stated has been left open by a user and isn't being used at the moment, while you can take over active sessions as well. The legitimate user will be forced out of his session when you do so, well, which could be noticed by them. To connect to a session, we can use testcon exe and specify the session ID will be taken over. as well as our current session name, followed by the previous example. So we'll take over Luke's session. If we were to connect as administrator user, we would do the following. In simple terms, the command states that the graphical session 3 owned by Luke should be connected with RDP session, RDP TCP6 owned by the administrator user. As a result, we will resume Luke's RDP session and connect to it immediately. Note that Windows 2019 won't allow you to connect to another user session without knowing its password. Great. Let's get to work. To complete this exile, we'll need to connect to THM2 using a new set of credentials obtained. Notice this link is different from the link. See a new set of credentials. Once you have your credentials, connect to them. Okay, so we need to use a new set of credentials. Okay. Well, okay then. So let me just move this a little bit over to the right. Let's come over here. Just grab a new set of credentials, new set of threads. Come over here and I'll go back to, or actually I'll just start up a new session. Open up Chrome. Copy over this. So it's asking us to get creds too. And this link is different from the first link. So I was gonna actually use the first set and just say, I can do what I want. But then I was like, wait a second, that's a different link. I can't do whatever I want. All right, so we'll let this connect here. Get the creds. All right, I'm gonna copy this to my little fancy graph over here. Oh, we got all these creds. Way too many creds. All right, so let's go here, do a new text box here. So I'll put the creds right here at the bottom. All right, let's make this white. All right, good. Now I'm copy these creds and put this into a mouse pad. And I really like this option right here of like being able to switch desktops. I'm gonna start using this more often. All right, great. So we got the creds there as well. Come over here. And we want to RDP in. All right, so these credentials will grant you administrator access to THM2. Okay, so we're gonna need to use this username. Password. Grab that, come over here, open up a command prompt, drop it in there. I don't know if I have X3RDP installed. I have to use Marina. Oh, hey, it's working. All right, cool. So what's next? So for this task, we'll work on hijacking an RDP session. If you are interested in trying backdooring exe or other files, you can find exercise about this in the Windows local persistence room. Find the instructions to hijack one Beck RDP session on THM2 to get your flag. When executing query session, you'll have several usernames, one Tom Becky followed by a number. These are just identical copies of the same user, and you can hijack any of them. If you don't need to hijack all of them, make sure you hijack a session marked as disconnected to avoid interfering with other users. All right, so let's go here. So, okay, so we got our session here, and then we're gonna use what we learned to hijack the session. And since we're hijacking it, we're not using any of the backdoor BBS scripts, which look super cool, and I kind of wanted to use those, but it is what it is. So we'll open up a command prompt. as administrator. And then we'll run this command here, the ps xx64. I don't know where that file is located. Let's see if it's here. Might be under tools. Yeah, so that's probably under tools then. So what I'll do is I'll cd c/. Let's actually check to see it because you could just open up the file since we have the GUI here. Here we go, tools. So yep, there's the tool right there. That's what we needed. So go on tools. And now we'll run that same command from here. And we'll click yes. Mark Rasinovich. That was the dude who created it. All right, next we'll query the session. Query user. We can see there's quite a few sessions open here, so we'll just have to pick one of these. So we'll pick this one's active, so I guess we'll pick that second one. So now I'll do TC con TCS con 2. Oh, 8. It's 8 slash dest RDP TCP. What's the number on that? 0. Enter. Oh man, we're getting access denied. Why is it giving me access denied? Let's try 4 instead, I guess. So yeah, that works. And then look at BIM, nice wallpaper. So that's your flag there. All right, next we'll go on to port forwarding. I am running low on time, so we need to like book it. All right, let's see if I got, I don't know. Oh, added, oh, just add some more time. All right. Yeah, it's getting late over here. All right, so let's see. We got SSH tunneling, attacker, SSH into the PC1, port forwarding. SSH tunnel with port forwarding. Then we send it to our local machine, which then knows that when it receives a connection locally to forward it to this other machine on 3389. So then we can forward it from here to here and back. All right, and then port forwarding from here to say when we get a connection from there, send here to the local session. Oh boy, this is always getting me confused. I always look at this like, oh, this is confusing. So SoCat's a good one. I hope we use SoCat. SoCat 3389. Listen. TCP 4. So this one. Fork it to 333. And then there's a SoCat client here. So you have SoCat on this machine. And so it will take any connection it receives on 3389 here and forward it here. And then we have to Create a firewall rule that allows us to do that. And then we could also use different ports like port 80 for websites. And then you have socks. Socks is a good one. All right, so this is the let's get to work part. Yeah. Yeah, so let's just get to work on this one because this is the last one. Since you'll be doing SSH connections from the lab, from the net lab back to your attacker machine using the tunnel user for this task, we highly encourage that you use the attackbox or VM instead of your attack machine. Instructions have been given on how to create a user that won't allow running commands or transfer files via SSH, SCP, so to be sure to follow them as provided, as recommended to create a strong password for ton user and make sure that it's unique and discardable password, not your actual password in this or any other platform. To complete this exercise, you will need to connect to THM2 using the credentials assigned to you in task 1. If you haven't done so yet, click on the link and get the credentials. Once you have the creds, connect to THM2 via SSH. Okay, let's drink some water real quick. So we're gonna use these creds that we used in THM1, which for us should be kind of easy because I have the command right here. So in my diagram, it's actually paid us off. All right, gonna grab those creds that we used in the beginning. I'm just gonna come over here. I'm just gonna create a new desktop. Dang, can I create a new desktop? I think I maxed them out. I don't think I can create any more new desktops. I'm gonna have to just close this one out. Just clear this out. And then we'll just work off of this one right here. So just put it down here. All right, so there we go. We got jump information over here. Drop that baby in there. Boom. It's gonna ask for the password right now, so I gotta get my diagram up. Let's get that password. Drop that password. Boom. We're in. All right, cool. So next we have our first objective we'll use to connect via RDP to THMIS. If we tried to connect directly from our attacker machine, we will find that port 3389 has been filtered via the firewall and therefore is not available directly. However, the port is up and running, but can only be accessed from THM2. By using SOCAT, which is available in the tools SOCAT THM2, we will forward the RDP port to make it available on THM2 to connect from our attacker machine. And this is actually normal. It's normal for environments to have jump boxes because it's like a security thing. So the fact that you would have to gain access to one box and then from there jump to another box is pretty spot on. All right, let's go here. That didn't let me. So go CD, drop that in there. Now we're here. All right, then we'll do dir. And then we have SOCAT. So this is going to be, we're basically using it like a proxy, right? So SOCAT exe is right there. So then to do so, we will run SOCAT using the following parameters. SOCAT. I'm just going to actually take these parameters. It doesn't look like we need to add our IP address in there. Huh. TCP4, listen. Note that we can't use port 3389 for our listener since it's already being used in THM2 for its own RDP service. Feel free to change the port from 13389 to a different one to avoid clashing with other students. In a typical setup, you'll have to add a firewall rule to allow traffic through the listener, but them jump to has its own firewall disabled for your convenience. Oh, thank God. All right, so let me just throw this in there. We'll change that TCP listener because I'm 100% sure there's somebody out here using the same port. So I'll change it from 133.89 to 135.89. All right, enter. Once the listener has been set up, you should be able to connect to them IS via RDP from your attack host by pivoting through your SOCAT listener at them jump 2. Once connected, you should be able to get the flag. So grab this command and we'll just modify it a little bit. So go here to my mouse editor, just drop that in there. Name this 1335, right? 135. So when I send a request to 135 via jump 2, and for us it's going to be Thomas Moore. It's then going to forward that request to the MIS. Right, so from the jump to the MIS. So let's go to this diagram here and just kind of go over what's going on here. So essentially what's going on in all this madness is that we have set up SOCAT on Sim. I'll put a lightning bolt. We set it up SOCAT on them jump 2 right here, right? And so what it does is it'll take the traffic, we send it, and we send it traffic. It knows to then send that traffic to them IIS here, right? I'll delete this. And to use those credentials to authenticate and RDP into it to connect to it. And it knows, SOCAT already knows to send that back through it as a proxy to us. Okay, so it's getting sent and proxy to us. So great stuff. Let me go to my mouse pad. Everything looks good here. Grab this. Go ahead and open up a new terminal. Paste this in and we should be set, hopefully. So yes. And we're in. We are in. SOCAT is amazing. I love SOCAT so much. There's our flag.bat, so we just run it. We should get the flag. Here it is. Them site beyond site. Let me see if I've actually done this one. Them site beyond site. Nice. What is the flag obtained using Rigetto HFS exploit on them DC? So this is probably the same thing, except you're doing it through port 80. See? So how much time we got? Let's see here. Let's just make sure we got enough time. So we have 1 hour. So looks like second portion, tunneling complex. We did this portion here. So tunneling complex exploits. So the THM DC server is running a vulnerable version of Rigetto HFS. The problem we face is that the firewall rules restrict access to the vulnerable port so that it can only be viewed from them 2. Therefore, furthermore, outbound connections from them DC are only allowed machines in its local network, making it possible to receive a reverse shell directly to our attacker's machine. To make things worse, the Rigetto HFS exploit requires the attacker to host an HTTP server to trigger the final payload. But since no outbound connection are allowed to the attacker machine, we would need to find a way to host a web server in one of the other machines in the same network, which is not at all convenient. We can use port forwarding to overcome these problems. First, let's take a look at how the exploit works. First, if we connect to the HFS port, R port in Metasploit to trigger a second connection, the second connection will be made against the attacker's machine on serve port, where a web server will deliver the final payload. Finally, the attacker payload will execute and send back the reverse PowerShell to the attacker on out port. Okay, so send to HSFR port, that's the remote host port, request payload via HTTP. So it looks like we're doing the stage payload. So it's like, okay, hey, give us the payload versus the service port. And then send reverse shell to attacker, right, on the out port. All right, so with this in mind, we can use SSH to forward some ports from the attacker's machine to them, jump to serve port for the web server and out port to receive the reverse shell and pivot through them jump to reach the R port on them DC. We would need to do 3 port forwards in both directions so that all the exploit interactions can be pivoted through the them jumped box too. So it's going to connect here to them jump 2. Then jump 2 is going to SSH tunnel that over to us, and we're going to be listening probably on our local port so that we can get the session. So if I lost you, it's just bear with us. It's going to be complex, yeah. Rigetto HFS will be listening on port 80 on THMDC, so we need to tunnel that port back to our attacker machine through them jump 2 using the remote port forward. Since the attack box has port 80 occupied with another service, we'll need to link port 80 to them DC with some port not currently used by the attack box. Let's use port 8888 when running SSH in them jump 2 to forward this port. We would have to add this rule, okay, to our command. So just look at this here. So this from them jump 2 is command prompt. We're going to use SSH tunnel user our attacker IP on 88888, which if we look here, it doesn't say THMDC 80. So we can reach that web server on port 80. Local port that we're going to be listening on our Kali box is going to be 127.0.0.6. And holy crap, this is a lot of information. Sorry. And let's see here. This is kind of a lot. All right, so let me look at this here. So in our box, listening on 7788, 777. Oh, so this is us right here. So this is us listening. And this is the tunnel on ThymJump 2 listening. And this is its forwarding action. And this is a lot of information. All right, so then, all right, guys. So what I'm gonna do is I am gonna go take a walk because my plane is about to explode. Okay, so this is making kind of sense now. This set our host. This is going to be our local host, which is kind of this one, I guess. It's essentially the SSH connection. Boom. SSH connection from us to our proxy, right? And then this right here, this is going to be from proxy to our service port, which is this one. It's a second connection. And then this right here is going to be a binded connection. That's going to say, listen for a connection once this is run. Listen to your reverse TCP connection as our proxy and just bind that to 7878, which is this will bind both ports on them jump to and tunnel any connection back to our attack machine. But we do need to modify this service port and the out port for 7878. A little confusing, but I think we can work with this. So let's go ahead and get logged in here. Just one sec. All right, I'm logged in. And we see this here. I need to close that out. I think we're using the first credential still. Yeah. All right, so we're using those first credentials we got. So go ahead and close this out. And we're still here, so we can go ahead and just end that process there. All right, and next thing we're gonna need to do is just make sure that we have everything running. All right, great. So let's go ahead and open up our mouse pad. I'm just gonna do this. And I'm gonna start altering this. Command. Put in our IP address for that. Okay. Then we got 88888, which is going to be the SSH tunnel. And we don't need to change that. I don't believe we need to change that. But we do need to change the 6666 and the 7878. So 6666 here needs to be changed to the 66 or 670. And then six 670, and then 7878 will change to 785. Great. And we'll copy the original commands so that we're kind of like not confused as we're adjusting things on the go. And let's see here, SSH tunnel user, SSH connect back to us on 8888. It's going to forward any connections via this port. And 6666, this is going to be, it's going to forward those connections it gets to our service port. And then let's see, 7888 is going to be, I want to say that's going to be the HSFR port, but I could be wrong. So let's try this. Let's grab this copy, drop that in there, press enter. Yes. This is me connecting to my machine. So I'm gonna go ahead and pause it, but just know you're connecting to your own machine, so put your own password and such. You may have to run SSH server. We'll see. We'll see if I can even get it. So I'm gonna walk you through this one. So for the default, right, your default is Kelly. So for the tunnel user, it's gonna be Kelly because it's just a SSH session to your machine. So Kelly, and it should look like this, right? So it will ask for your password. I'll see if it works now. Um, so I just realized that. All right, so now it should work. All right, pause it real quick. Okay, so another thing you're gonna need to do is you're gonna need to make sure you start SSH server. So the way you do that is you just type in this command, system equal enable SSH, and this will start the SSH server on your Kali box. It's not started by default, and you typically have to start it every time you start a computer, basically. So that's the command you're going to run. Once you run that command from another command prompt, just open up a command prompt and just type it in there. Boom, just like drop that thing in there. And just delete this portion. Boom, it's going to ask for your password. Put your password. It's going to start the server, then run the command. Okay. Then you're going to run this. Okay. Then it's going to connect. Then it's going to have this like connection between you and this other machine, right? So now that we've done that, we can now set up this interpreter and use the ports that we specified earlier. So let's go here, MSF console. And I think I'm starting to understand this a little bit better. I might want to diagram this out, but I mean, come on, am I going to remember this a few weeks from now? I don't know, maybe. All right. So we're going to use Rigetto. Rigetto. Set the payload. So they might have some script on this other machine that's just running this payload all the time or something. I don't know. Set the outhost here. I feel like we would need to get the payload. Like we'd have to get this payload to the other machine. They didn't say anything about that. I guess we'll see. So that, let's go to our mouse pad. Dang it. I was supposed to change this one too. That did not change it. Dang it. All right. 85. It's supposed to be 7785. Oh, gosh. All right, so I'm going to go back and change this real quick. Oh, this is gonna suck. Let's go back up here. Dang it. All right, so let's see if I can set this up. I'm probably gonna mess it all up. Okay, hold on. All right, so we're putting in all the commands, run an exploit. We'll see what happens. Hopefully it works. And it failed. Okay, so why is it failing? Lhost. Failed to validate lhost. What did I put for lhost? Oh, the jump server. let me check on that. Okay, I don't know why it's not working for me, so what I'm gonna do is I am going to probably restart my computer and see if I can get it to work. Um, Before I do that, let me just save these notes and I'll restart it, see if it works. If it doesn't, um, just know that the flag, I'll scroll down, right, because I might just be running some issues, is them forwarding it all. That's it. Them forwarding it all. Okay. But let's go ahead and try this real quick. All right, we got it to work. How did we get it to work? Well, let's look at it. Let's look at this. All right. So first of all, let's go back to the payload. So what you're doing is, and I'll put this in my notes. This is going in the description. Everything goes in the description. I don't know if you knew that, but it's usually what I do. So there we go. All right. So here we go. We established a session with the jump server, right? We then ran this command to connect via SSH from that jump server to our attack box. Yes, yeah, this attack box, the Kali box I'm currently using, right? Now, before you did that, you have to make sure that you run this command to start SSH. Otherwise, your jump server can't connect back to you. So once you run this, then you want to run this actually. So let me just go ahead and change the priority of this command. All right, there we go. All right, so then make sure that you keep this 8888 port the same. Why? Because it doesn't really matter. That's the connection from the jump box to you. I mean, just keep that. Nothing's gonna happen if you leave that as is. All right, then you have this connection that's gonna be forwarded to the domain controller on port 80. So it's gonna connect to the domain controller on port 80, or maybe this is a web server. Let's look at the topology. Nope, that looks like the domain controller. That's the domain controller. All right, so then it's going to connect to the domain controller on port 80, and it's going to do so from port 6670. It's going to be the listening side of the, let's go to the notes here. It's going to be the listening side. The service port. So the service port, it needs to connect back to us as well, right? So that needs to connect back to us. It's going to request a payload via HTTP back to us. So we're posting like this payload, and then it's going to connect back to that. And then you've got this other port here. This is 7885, and I just changed it. It used to be 787078 right here, and that's L port. That's going to be our listening port for this connection. So that's going to be the L port. So as you see here, it's going to be the L port here, SVR port here, and we're going to be listening on our SV port here, our L port here, and it's going to go through our SSH tunnel here. And so when we run this, what will happen is that this will send, and this is the important part, it will send this traffic through this SSH tunnel to us. And on our side, we're also listening for that. Right? And we've set it to have this reverse listener bind on 121, our local port, the L port. So we're specifying this information, SVR and L port and R port. Okay. Our hosts are the local ports again, or the local IP addresses for everything because we're using dim jump 2 as our basically proxy. All right. And then 8888 is our 888, that's the SSH port. So that's port that this SSH tunnel is using. That's the 888 port there. So we have this SSH tunnel between us and jump server 2. All right, we run that exploit, and what it's going to do is it's going to start reverse TCP handler here on 7885. 7885 is the out port for this reverse listener bind address. It's then going to forward this, and this is where you're going to probably run into issues. But that out port, just make sure that you, if you run into this error, make sure you change it to the actual IP address of the domain controller. I want to say, or was that the yes, let me double check which one that was. Oh, that's the jump box. So that's the L host, because obviously we're listening for connections back from the L host, right? Which is in this case the proxy, which is the jump box. So our L port has to be the jump box. So make sure that that is your dim jump box. That has to be this IP address for the dim jump box. Okay. Don't leave it as this dim jump box 2, because I don't know if I'm running into some DNS issues, but it's just not resolving. Once you do that, it will know to listen for traffic from that through the reverse listener bind, and the payload requested will be sent, and we will establish a session. And so once we establish the session, we will connect to this SFHS server and run our Rigetto exploit, which would then give us access to the server. So then if I do dir, and there's a flag, so type the flag out. There it is. There's a flag right there. Them forwarding it all. All right, so to recap, what I'll do is I'll just kind of grab this command here. I'll grab all these commands here. All right, go ahead and grab that. And we'll paste that in the notes. And we'll change this to the IP address of the, I'll just make a note in there that that has to be the IP address of the jump box. There you go. That way you can see that. It kind of flags it. You put the IP address there. So once you do that, everything should work. Still a little confusing, so let's go ahead and just go over it one last time to kind of just clarify any confusion here. So SSH port forwarding. In our example, let's assume the firewall has blocked attack machines from directly accessing 3389. As previously compromised PC1. In turn, PC1 has access to 3389 and can be used to pivot 3389 or remote port forwarding. Remote port forwarding allows you to take a reachable port from SSH, in this case PC1, and project it into a remote SSH server to the attack machine. A valid question that might pop up at this point is, why do we need to port forward if we've compromised PC1 and can run a RDP session directly from there? The answer is simple. In situations that we only have console access to PC1 and won't be able to access any RDP clients, and we don't have a GUI by making a port available to the attacker's machine, you can use a Linux RDP client to connect. Similar situations arise where you want to run an exploit against a port that can't be reached directly. As your exploits may require specific scripting languages that may not always be available at the machine you compromise along the way. Refer to the previous images to port forward 3389 to the server back to our attacker machine. We use following the command in PC1. Okay, so SH tunnel from our machine, right? So you're running this from this PC1. This is obviously a Windows command, and it's going to listen for any traffic it receives on 3389 and forward it to 3333 on 3389. So it's going to say you're using it as a proxy, right? So you've established this tunnel, and it's saying, okay, anything I receive from the attacker PC, I'm going to forward it to the server. Okay. So when we're looking at these commands down here, it's basically what it was also doing. It was forwarding it to the 7878, and the 7878 was the L port, right? So it was forwarding it to the L port there. So scroll back up. Command structured is similar to one that used in remote port forwarding using L option for the local port forwarding. This option requires us to indicate the local socket used by the PC1 to receive connections 80 and the remote socket to connect from our attacker's PC perspective. So listening on this one, and then sending here. All right, notice that we use the IP 127.0.0.1 in the second socket as the attacker's PC perspective. That's the host that holds the port 80 to be forwarded. Since we are opening a new port on PC1, we might need to add a firewall rule to allow the connections. All right, so 80, so that's between SH tunnel, connect to the attacker PC, do so over 80, and we're obviously using SSH as the tunnel, and for that traffic out to 80, which is in this case it will forward traffic out to port 80. Right. Once your tunnel is set up, any user pointing to their browser to PC1 at 222.2.80 will see the web site published by the attacker's machine. Okay, so anyone who visits this website will hosted on PC1 will actually be from the attacker's machine, will actually be tunneled by the attacker's machine there. So that makes sense. And you have SOCAT and dynamic port forwarding, which we didn't do. That's using like proxy chains. We would have used proxy chains if we had done that. All right, so pretty great information. I think that will wrap it up. We have the conclusion here. There's more tools you can use like shuttle, rpivot, chisel, and there's definitely other rooms that can teach you this. If you're interested in learning more about this, they have Hack the Box Academy has their own room. And as far as Pen 200, there wasn't a whole lot of pivoting. I think they teach you how to use chisel. SOCAT's really popular. A lot of people like using SOCAT, so I'd say if you had to do it, use that. Or you could also use MSF Venom and MSF Console to set up your payload, MSF Venom, and then MSF Console with Metasploit or Meterpreter to set up your routes as well. It's also a good option. So let's take a look at SOCAT actually. So while single port forwarding works quite well for tasks that require access to specific sockets, there are times that we may need to run scans against many ports of hosts or even many ports against many machines. Although a pivot host in these cases, dynamic port forwarding allows us to pivot through a host and establish several connections to any IP address ports that we want to use SOCKS proxy. Since we don't want to rely on SSH server existing on a Windows machine in our target network, we will normally run SSH client to establish a reverse dynamic port forward with the following commands. So here you have SSH and then your user that you're going to connect to on Kali box, and then the IP address, and then you have the port 9050 because you're going to SOCKS proxy it. So in this case, the SSH server will run a SOCKS proxy. All right, so in this case, the SSH server will use SOCKS proxy on port 9050 for any connection through the SSH tunnel where that are finally proxied by the SSH client. In most cases, you're probably not going to have SSH clients, but you'd still use SOCKS proxy. The most interesting part is that we can easily use any of the tools through SOCKS proxy by using proxy chains. To do this, first we need to make sure that proxy chain is correctly configured, and you just need to make sure that 9050 SOCKS 5 is being used, I guess, or SOCKS 4, whatever you're using. And so yeah, here it is right here. SOCKS 4 localhost 9050. And then whenever you run commands, it's going to run it through this, which in turn will run it through your proxy that you have set up, right? Through SOCAT, if you wanted to set that up SOCAT, then you could run it that way. So let's see here. That's how that works. And all right, that concludes it. I hope you enjoyed this video. It took me a while to record it all, about 3 or 4 hours, because just running through issues and troubleshooting stuff and taking breaks and stuff. So anyhow, please like and subscribe. Danny out.